Welcome back. This is our second installment, Sedimentary Rocks with Mrs. Spencer. So if you remember last time, we said that rocks are made out of minerals, and rocks are classified by how they form. So we already did igneous, our lava and magma rocks, and now we're going to do sedimentary rocks. So sedimentary are the second most common type of rocks, well, they're the most common on Earth's surface, and they are formed by weathering and erosion. So let's look at what weathering is first. So weathering means rocks getting broken down into pieces, and they can be broken physically or chemically, like when we did physical and chemical changes. So physical is just changing the appearance. So we can have earthquakes, freezing, plant roots, wind, glaciers, or animals. So earthquakes happen when the Earth's plates are trying to move and they'll get stuck. And eventually enough pressure will build up, they'll move past each other and we'll get these big cracks in the earth. So anytime we have an earthquake, we have a lot of weathering happen, rocks breaking into pieces on these fault lines where the earth's moving past each other. So water is one of the most powerful forces on Earth, and it's not just because of rivers and rain and things like that. It also has one very special property that no other material on Earth even has. So we're going to do a little experiment with that so we can see it. So I'm going to take a Fanta, my favorite soda. My husband's mad I'm using the Fanta. He wants me to use a different soda. We're going to take it and we're going to put it in the freezer overnight and see what happens. So if you do this at home, you can do it with a regular can of soda too. The number one ingredient is water. You're just looking to make for a high water content. So I'm just going to put it in the Tupperware, and then we're going to pop it in the freezer till tomorrow and see what happens. Hopefully, I don't make a mess. Alright, check back tomorrow. So the next morning, I went to the freezer and check out the Fanta. So when I opened it up, see how the liquid has expanded. So when water freezes, most things when they freeze, they get smaller, like all the particles get closer together. But with water, it gets in this cool crystalline structure, and it actually expands when it freezes. So that's why the bottle kind of opened a little bit. I actually found the cap inside the freezer, but the bottle didn't break. Didn't do quite what I wanted to do, so we're going to try it again with the can of soda. Old Zevia, that carbonated flavored water thing. So take the Zevia. We're going to put it in the freezer overnight, same Tupperware, see what happens. So I took it out of the freezer the next day, and I found the lid already across the freezer. So let's see what happened. Oh, yeah, busted a hole right through the Tupperware. So the can of soda worked better. It's definitely thinner than the glass. But yeah, the water inside expanded when it froze. So if this was a rock, it can crack rocks. So if water gets stuck in a rock and then it freezes overnight, it can crack it right in half, just like my Tupperware. Plant roots can also physically break rocks. So you see my tree in the backyard, how you can see the root growing through the rock. It can break right through the middle of rocks, through the sidewalk, and even the foundation of your house. Wind can also cause a lot of weathering. So as wind blows against a mountain range, it can not only blow pieces off, but it can cause abrasion. So that's like sand in the wind rubbing on other rocks and causing them to get smoothed over time. So wind is a big cause of weathering as well. Glaciers are a big cause of weathering. Glaciers are big masses of ice on Earth's surface, and they're actually moving. They're not just sitting there. Some of them can even move up to like 30 meters in one day. Some of them will move that in a whole year. It just depends on the glacier and how big it is. But as glaciers are moving, they're dragging all the sand and rocks beneath it and scraping them along the surface. So glaciers can cause a lot of changes on Earth's surface. They can create big valleys. They can create fjords, they can create lakes, and totally recreate and reshape the mountains around us. And we can look at things now where there is no glaciers and how they were created by glaciers. Animals can cause weathering as well. because some animals burrow in the ground to create their homes, right? Like Walter is a tortoise, so when he goes to sleep at night, he goes into a burrow that he's dug. Chemical weathering would be more like water dissolving through rock, or oxidation from water, or plants or acid rain creating acid. So right here, I'm going to show you a little bit of chemical weathering. So this is a piece of chalk, which basically has the same chemical makeup as limestone. So one of the chalk, I'm going to stick into a cup of water, and the other piece, so as you can see, when it sits in the water, it starts to bubble already. So the water's seeking into the chalk, which is like going to be an example piece of limestone, and starts to dissolve it right away. So it's basically like getting rid of the limestone or getting it into the water so that maybe when the water evaporates, it'll leave some limestone behind somewhere else. And then in my other cup, I'm going to add vinegar. So vinegar is an acid. So this would kind of represent maybe like acid rain or acid leaking from a plant or something like that. But acid doesn't mean it's going to burn you. It just means it has a low pH. So it's a lower pH than water. So you see when I drop the limestone in there, it immediately reacts and starts to bubble. Do you remember when we talked about acidification in the ocean? So limestone is made of the same type of things as corals and different animal seashells. So it reacts a lot with these acids. So if you remember from our last unit, where we talked about how animal shells don't form correctly because the ocean is becoming too acidic. So that's why this chalk is breaking down so much immediately. You see all the bubbles? So acid has a big effect on limestone. So the more pollution we get in the ocean, the more corals and things are going to break down like this. So I left it here for a few days, and you can even see it start to break down, and the bubbles are still happening in the vinegar a few days later. After I left them for about 4 days, I took them out and just kind of took a look at it. But if you see any like indentations, the water didn't quite dissolve it as much as the acid. This one is the one that was in the vinegar, but you can see like the little divots and things like that. So the longer something is exposed to acidic water, things like that, acid rain's caused a lot from pollution. So the rain coming down and going through pollution, it can wear down rocks and things like that as well. There is some weathering in my backyard right here. If you can see this line right here in the brick, what do you think caused that? Do you see where it's coming from in these lines? What is it leading to? You see all these little divots and things all over my wall. My house was built in 1971, so we have a little more damage than some other places because it had more time. But if you can see along the wall, it leads back down to my sprinklers. So this is where the water's hitting the wall every day. So it not only causes like mineral buildup, but the water is basically tearing a hole in my wall. All right, so we got our orange rock. You should know this by now. I feel like Dora the Explorer. What is it? Oxidation. So this rock is gonna start breaking apart too, because once something rusts, it weakens the chemical bonds in it, so it's easier to break it into pieces. You can see the green parts too. So remember like the Statue of Liberty, when you talked about that, that used to be copper and it turned green. So there's definitely some copper in this rock too. But what element's the one that turns rusty? It's iron. So this guy has iron in it and he has copper in it. But it'll be easier to break apart in the rain now because it's rusty, oxidized. I found some lichen too, which is, lichen is a mutualistic relationship between bacteria and fungus. So it's growing on the side of this sandstone up by Lake Mead. And what happens is when moss and lichen grows on rocks like this, it leaks acid from the plants. And slowly over time, all the acid that's leaking from the lichen is going to wear down the rocks. And you can see little holes and divots and caveats in the rock where the lichen is wearing it away over time. So after rocks have been weathered, which is broken into pieces by all those different things we talked about, erosion's going to happen. So erosion is when the rock particles that have been broken from weathering are getting moved to a new spot. So generally, the biggest one that erosion is caused by is water, right? We got rivers, we got oceans, we have rain, we have lakes. Any type of precipitation is going to move these little sediment, which is broken pieces of rock. That's why they're called sedimentary rocks, because they're made of broken pieces of rock, which is called sediment. The wind can cause this as well. It can also just be gravity. So you can have rocks higher up on a mountain. There's an earthquake, there's something, it gets pushed downhill. But this, as erosion's happening, it can carve deep valleys. Things like the Grand Canyon, places like that have been carved by this erosion. So it's just moving these rock sediments from one place to another. So rock is first weathered into pieces, then erosion happens where it gets moved into a new spot, but then the rock has to be compacted and cemented together, or else it's just sediment, it's just sand. Like that's what sand is, it's just sediment, it's broken pieces of rock. So I'm making a sedimentary rock here, just kind of like a little piece of sandstone, and I add a little limestone on top. But basically I'm just taking a little bit of sand, well, it's more like rock soil from my backyard, and I threw a little food coloring in it. And then we're putting it in the cup to compact it. So compacting just means like layer upon layer upon layer is sat on top of each other. So they kind of just push down. So sedimentary rocks generally all have layers in them. You can look down and see where they formed. If they formed chemically, then you might not have layers, but most of them do. I also added some water and some plaster. So the reason I added plaster is that's kind of like the cement that's going to stick it together. So usually what sticks cements these rocks together is you have some kind of mineral that's dissolved in water. It can be salt, it can be calcium, something like that. And as the water evaporates, these minerals crystallize and they'll kind of just glue all these rocks together. So I'm just throwing in a couple layers of rock over the top of each other, right? So this compacting these on top of each other. In nature, this would take hundreds to thousands to millions of years, but this is how red rock was formed. This is how Valley of Fire was formed. Any kind of sedimentary rock formation that you can see was formed this way. And then there's something special about sedimentary rocks. These are our fossil rocks. So I'm going to take a little mousse and stick it right there in the top of my little sandstone layer. And then I'm going to add another layer of rock on it. So this is how fossils are formed. Yeah, so sedimentary are fossil rocks. So something dies, and then it'll get buried in sedimentary rock. So it can get buried in sandstone, shale. It doesn't matter what type of sedimentary rock, but it gets buried. And then over time, other layers of rock get laid on top of it and kind of bury that fossil. So probably what would happen is the animal or the plant would decay over time and basically just we wouldn't see it anymore, it'd become part of the rock. And then we would have kind of like a mold or a shape of where the animal was. Or sometimes what'll happen is minerals will seep into the bone of the animal and we'll have like a petrified fossil of the animal. So I got all my sandstone layers, but then I want to add some limestone on top. So limestone, I added a rhino too, so now we have 2 fossils in there. So we have a couple different, we have a green, we have blue, we have red sandstone. And then I'm going to use plaster and water, which is basically the makeup of limestone. And I'm going to pour it right on top. And then this plaster and the sand, I'm just going to leave to let it harden for a few days. So after letting it dry for a few days, I take my sedimentary rock I formed and I'm going to cut the cup off. So now I have a piece of sandstone on the bottom and then, sorry, Lucy's in the way. And then the top is limestone. So if you're looking at a sedimentary rock, you always know the top is the youngest and it gets older as you go down. Because the first layer I made was that green on the top, on the bottom, and then the top is that plaster. But it's still a little wet, so I'm going to let it sit in the sun for a few days to let it get a little drier. All right, so my rock's dried out. And now what we're going to do is try to find our fossil. So I picked out that piece of limestone, and you can see the indentation where the rhino was. It's kind of stuck in the plaster, so it's going to stay in there. And then if we dig a little deeper, then we can find our moose fossil. I have to dig through it a little bit to find it. But this is how scientists can kind of guesstimate how old fossils are. So the deeper you go in a layer of sedimentary rock, the older it is. So I know that this blue rock formed first, and then somewhere in between there, the moose died. And then this red rock was laid on top, and then the rhino died, and then there was limestone on top. So that's kind of how scientists can figure out the relative ages of rocks. So the deeper you go, the older it is. The youngest is on top because that's a layer that was laid last. So the older the fossil, the deeper it is in earth. The first type of sedimentary rock we're going to look at is organic, and that means they're made of the remains of plants and animals. So even though minerals can't be from living things, rocks can be. So our first one's coal, and coal, if you remember when we did energy sources, is made out of the remains of plants. So you had some kind of ancient forest, probably in a swampy area, and the forest died millions of years ago. And over time, the plants get pushed downward, and there's a lot of pressure and heat on it. And over time, it's going to form coal. So these are two pieces of coal. You can burn it, right, for energy, because that carbon that was inside the plants came from the sun. And all that energy that we have inside of us from the sun can be burned for fuel. And then we have limestone, which is actually made out of the remains of marine fossils. So the calcium and the bones from corals and shells and things like that compress over time at the bottom of a seabed or an ocean, and then it compacts into what we call limestone. Our second type of sedimentary rock is chemical. So these are made when minerals that are dissolved in water crystallize, and then we can see them come out of the water, like at the dry lake bed. So to model this, I microwaved some water to get it nice and hot, because if you remember, things dissolve better in hot water because the particles are a little more spread out. So I add in my salt, and then I just mix it up and mix it up and mix it up. And then I basically just kept adding salt until it stopped dissolving. So I have a saturated solution of salt and water. And then I just took my cup of salt water and I left it in the window for a few days. And then we're going to go on and check on it once. Here's Lou. So this is about 2 days after, and you can already see the water is starting to evaporate, and you see how the salt has come over the whole side of the cup and the spoon. So as the water evaporates, it's moving the salt upwards. And then this was about a week after, maybe, and most of the water has evaporated, and then we have these salt crystals everywhere. So this is how like a salt bed would form, like at the dry lake beds and things like that. It can form on the sides of the ocean, and different kinds of minerals can form this way too. We can have gypsum. Limestone can form this way as well. You can have caverns where you have stalactites hanging from the ceiling that can form this way as well. Our last type of sedimentary rock we're going to look at are called clastic, and these are rocks made of rock fragments that are just squeezed together. So I went up to a place kind of by the school at Sunrise Mountain, and they have a bunch of shale up there. So shale is a mudstone or clay, but if you see it has like little layers on it, it can break off into pretty flat pieces. This is some of the stuff that cemented it together. It might be some calcium or some mica in it. But this is a great rock for fossils. So if you ever want to go fossil hunting up here, you can probably find a lot of marine fossils up here. They're different animals that have lived in the oceans. So if we have marine fossils right behind our school, what does that mean? Yeah, that's right. We used to be underwater over here. So the glaciers at one point were melted and we were underwater. So all these marine animals lived here. But yeah, this is called shale. There's great deposits up there that are green colored. And it's basically just a mudstone or clay. So mud or clay has settled to the bottom of the ocean, and formed into different layers. So any kind of sedimentary rock that's not that's clastic, you can see little layers in it. They're usually pretty breakable too, and can kind of like break right into flat little pieces. So this isn't something you'd want to use as like a building material, but it's great for fossils, and it's kind of a cool little adventure if you ever want to go behind the school and check it out.
Go ahead.
So you can also find pieces of limestone up here. And limestone is like a chemically formed rock. So what happens is as marine animals die, their bones and the calcium inside of them sink to the bottom of the ocean that they're in. And eventually over time, they'll compact together and make a rock. So that's what limestone is. It's definitely more sturdy than shale, which is just kind of like a mudstone. And that's actually what Mount Charleston is made of. So if you go up to Mount Charleston over towards the west side of the town, it's all made out of marine fossils, really, just compacted marine fossils. My husband had a really good find. See how this rock right here is in the middle of weathering? See how it's breaking into pieces right now as we speak? So we've been having a lot of rains lately, so that's probably what's been breaking it up. But it could be animals, but see how you can just break the pieces right off? So this is like a giant piece of shale. It's still shale, like it breaks really easy. It's just a big giant mudstone, but it's in the middle of breaking down. So now it can change. Ooh! So when I lift it up, you can see indentations. So you could probably break this open, and if you took a hammer to it, you could probably find some fossils inside of it. But if you ever want to come up here, it's only like from the road from Lake Mead Boulevard, it's like a third of a mile of a walk right past Los Feliz Street. You just park, and then it's like a third of a mile up here, and just look for on the left side when you're walking up all the green shale and flat rocks around.
All right, go ahead.
So we're walking over towards that outcrop over there. We just drove down the road a little bit further to get some sandstone. I was going to show you, I found a cool one. You can see all the layers. So what happens is this is a layer of sandstone that was formed, and it's just another layer, another layer, another layer, another layer on top. So when scientists are studying these rocks, they can go down deeper and know like these fossils were formed before these fossils. Okay, can you see this mountain over here in the distance? So we see how the lines are laid this way, like diagonally. So this is probably sandstone and shale and some mudstone, probably some limestone in that mountain as well. But you see how they're shifted diagonally. Well, originally it was laid up and down like this. That's how the sedimentary rocks are formed. And then some type of earthquake happened and the mountain shifted sideways. So if you ever see a mountain where the lines are going diagonally, there was some kind of earthquake or something to upshift where those mountains, how they were laid originally. So you can see sometimes they'll be this way, and then there'll be more on top that will be laid flat, so you can kind of say like when the earthquake was and then when rocks started getting laid horizontally again. So this is sediment that came off of the mountains over here, right? We have red in it, so it's probably some iron in this rock. But the sedimentary rocks get weathered away, and then by probably most likely wind and water. And then erosion is the movement, right? So weathering's breaking it, erosion's the movement. So it was weathered by storms or wind or whatever, and then the wind eroded it over here. And now we have little pieces of sediment. And eventually it might form back into another sedimentary rock later on. So when you're looking for sandstone, you're looking kind of like for layers in it, and sandstone's just like it sounds. It's made out of sand. So it's just sand that's compacted over time. Usually it's cemented together by like water. Sometimes there's like salt or something in the water that helps it stick. You can see all the layers. See like this white stuff? That would be like calcium or salt that was in the water, and that'll be like the cement, like the glue that kind of holds it together. This is also pretty breakable, so you probably wouldn't want to build your house out of sandstone either. But it's very common. And this is right in your backyard, so if you ever feel like going on a hike, this is probably maybe 10 minutes from your guys' house. So you can see this little path right here is where water is eroding all these little pieces of sediment down the mountain. So there's probably been big rains here or floods, and then the water is moving the sediment downhill. So sedimentary rocks, let's just review. They're made of broken pieces of rock, which are called sediment. So rock gets weathered, so broken. It can be animals, it can be pressure, it can be wind, it can be water, it can be glaciers, it can be plants. And then they get eroded, so they get moved by wind or water or ice or gravity. And then they get compacted together into layers and then cemented together, probably by minerals that were dissolved in water, crystallizing as water evaporates. So then we have our sedimentary rocks. Thanks for watching. I hope that you guys are all doing well. I miss you. There's Lou. Hopefully, see you soon.